Well, hey everybody. Again, thanks for that, Bob. And Corey's hiding back there too. He is doing some tech stuff in the background. But if you have questions, we're all trying to watch the chat while I speak. In 75 minutes, we're going to cover all of assessment. So as you know, that's just not possible. But I want to be the second or third person to welcome you to Patton's Math Summer Conference. This has been an amazing thing. I've been working with Patton for 19 years. My first sets of trainings across all the patent offices was back in 2006. How fun. So I feel like I'm getting a little long in the tooth. The little introduction, I am at Western Carolina University. I am a distinguished professor out there. My job is to bring research-based practices to as many schools as I can, not just in North Carolina, but across the country. And one thing I absolutely love here is we got people from multiple states. I've got my friend Andrea from the Kansas Math Project. Hey, Andrea, I saw New York. We've got Canada involved, and some of you are just hiding out from other states. Welcome aboard. Patton has been a leader in math ed for decades. And since Alan Muir to Jared Campbell to Bob, we keep rolling with great people. All right. The job of this talk right here is informed instruction and intervention math. We will start with the informed instruction. We got about 4 activities with a final kind of sum up activity. And each one of those activities will have a chance to kind of stop and work on something. Because of the condensed time, I did not reduce the number of slides. Like a lot of people have like key slides and make it really, interesting that way. I actually like more slides as a presenter so that in you and I, we can't get through all the details of certain things. You have the PowerPoint and you have the activities that you can go back and apply those. There are some great things at the very end in the intervention side that I don't know we're going to get to. I didn't plan on getting to them. If we go fast, I'm going to rock it. But that's how this is organized. So without further ado, let's keep going. So again, uh, as a researcher, I also write a lot of books. I think I've got like I've got 3 big pamphlets that are high selling right now, and it's really funny. Books are not research. Okay, one more time. I love my work. I work hard at it. When I dive into a book, I always choose research, outcomes-based research, not research on affect, outcomes-based research. And that is a big deal. The United States leads the world in affect research. What is affect research, Brad? Affect research is making kids like mathematics. I want kids to like math. I want kids to find math relevant. But those two in alone, according to the trends in international math and science study, are not equated to student performance, outcomes, or motivation. The one that is associated is student competence. When students believe they are competent in math, they work harder in math and they achieve. Now, that is a curious thing because then the chicken and the egg thing, right? Were they competent and then they did well? Or did they always feel that competence and they keep working, right? Were they motivated first and then? I get it, the whole chicken and the egg. We are going to talk today about how assessment can drive student understanding of the information, drive their feedback on the information, still give them corrections, but at the same time, give them that asset-based approach. So we're going to try to mirror that. But I did want to give my shout out to the books. Books can be fantastic, but remember, check the references. If the references are not research-based, they're not outcomes research-based, stay away. All right, so let's keep playing here. So what we're gonna do, I've got to minimize my chat just for a second, guys, just so I can read all this. We're going to start with informed instruction. It is one of the highest effect sizes in research. And I got to tell you, families focus on grades, teachers focus on learning. That is a disconnect that we have got to get through. Assessment is different. Assessment focuses on learning. Sometimes grades are connected, sometimes it's not. But the idea, the job of assessment is to get students to know what they're learning and for us to help reinvent and inform that instruction. And my little cartoon's not working. There we go. There we go. Fun. Got to have some fun. It's morning. All right. So assessment versus grading. Grades, summative judgment about what the student's performance was. Assessment, information to provide learning, right? To provide information for our learning and our teaching. It informs us how well students are doing in our classrooms. A lot of times our students think that assessment is for them. Assessment is really for us. It's for us to be informed about what we need to continue doing or change what we're doing. I worked with a school recently where the teachers thought they were doing great. They're actually one of the lowest performing middle school in the region. And so we had to go in there, and the teachers, they didn't like all the assessments. They were very upset at our assessments because it was the assessment's fault, not their teaching. And we had to explain that you're probably doing some great things, but we got to change some stuff up to improve student outcomes. When people ignore assessment, that's a problem. So we have got to help our teachers understand we don't need to spend 5,000 hours a year on assessment. What we need to do is spend targeted time to give us specific answers. So that's what we'll do today. 3 features today. We're going to talk about formative assessment structures. We're going to talk about using intervention content based on that assessment, and then how to connect evidence-based practices. So this is just a little fun. And if you play this game with me, my friends, because I got buddies out there, and I'm going to open up my chat. But if you play this game, please don't cheat. I'm going to show you a picture. There we go. And I'm going to ask, what is that a close-up of? This is an easy one. Little hit. This is like T-ball right here. So here we go, Carrie, lead it off and just type it in. What is that a close-up of? A lot of people thinking this is a leaf, 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 leaf. All right, guess what it is, guys? It's a leaf. You got it. So we're going to play this activity. I'm going to show you a close-up. You're going to tell me big picture, close-up, big picture. It's going to go a little longer than if you played this game with me before. This is the extended version. And then I'm going to show you what in the world that has to do with math and assessment. So here we go. What is that a close-up of? Type it in. Guys, look at you. You guys are so good. Football. I didn't think about that. Okay. So this, guys, is a close-up of a couch. Hence why it's fuzzy, because I had to be so close to get that fabric than the faraway shot. But that is a close-up of a couch. So again, close-up, distance. Here we go. Let's keep going. What is that a close-up of? Oh, intestines. Fluffy intestines. Maybe it depends on what you ate. All right, so I see, oh, fire. Oh, look at that. So, oh, I didn't think about that. All right, so cotton, batting, insulation, pillows. Here we go. It is a close-up, right? It is a close-up of a cloud formation. So looking through the clouds, hence the light behind it. That's pretty cool because it looks cottonish. Here we go. Another one. What is that a close-up of? And I promise this will go longer than desired because it's going to do something to you. Oh, cardboard, paper. Look at that. Construction paper, skin. You guys are great. Drywall. Oh my gosh. Awesome. Yes. Look at you. Cardboard, paper. Guys are good. You guys are good. All right. So let's keep going here. Now, what is that a close-up of? Curtains. Gotcha. But shark, gills, 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 gills. That's what's popping up repeatedly on my chat. All right. So most of us are saying it must be gills. You got it. Andrew, you cheated. You already know this one. It is gills. So we are getting closer and closer. Now, here we go. What is that a close-up of? How do you know this, guys? Okay, mushroom, veins, correct. Roots, more on veins, roots. Look at that of a mushroom. All right, if you're a biology lover, you should start loving where we're going with all this because you guys are on the right track. That is a close-up of the iris, right? It's all the veins in the iris, like looking into your eyes, the beautiful iris. And then you're like, oh, it's just veins. You got it, Gary. So Gary, see, I'm sure you typed that before I said the answer. So here we go. What's this a close-up of? Ooh, cells, flower, fungus. Yeah, we're starting to get a little all over the place here because it's getting harder and harder. All right. Okay, here we go. I'm gonna type it over. Jellyfish. Wow, right? It's the close-up of the jellyfish. Ugh. But and that's not the friendly kind of jellyfish, the ones that you want in the fish tank, that go around. All right. Close-up of, and we got about 2 more. Oh, good, good. Oh my gosh, I can't go back up and see who just wrote that in. All right, you guys are great. Oh my gosh, this is awesome. Oh, okay. Two of you have nailed it. It's the cat's nose, but yes, it is skin. I love that. And then my last one. What is that a close-up of? This is my last one, and it is a setup. Okay, see bread, skin, mole mole. Uh-huh. There we go. A rash. Oh, skin. Oh, now we're going. Look at you guys. All right, this is good. This is good. Okay, it's a pencil. So we did have a person saying their pencil. So here it is. This is what I want us to do now. I want you to reflect. How close were your guesses? And then if they're off, what distracted you? What made you say skin at the end? We actually set you up to say skin at the end. And I've done this differently where it's a little more direct to force you to say skin. But this one we bounced around a bit, but we still said skin. And then what in the world does this have to do with assessment? Because this is an assessment based um, uh, opening that I have had over and over again from other people. All right. So let me give you, let's do 1 minute. I'll check my timer here and let's get some answers there. Belinda, I think you're nailing it. See, you know what? I even pushed it on you, didn't I, Christopher? I shouldn't have said about the biology, but I got excited. It is a setup, correct. Oh, there you go. Why we focus on specific student work. Oh my gosh, you guys are so good. Close up, large view, close up, large view. All right, just so we're on the same page as you're typing out here, you might have noticed interventions are starting to have two different assessments on math intervention research. They have a near measure and a far measure. Not exactly what we did here, but a near measure. It's going to tell you how well they're doing right up front. So let's say I'm doing a multiplication intervention. It's going to tell me how well they're doing in multiplication. However, that child's in the sixth grade. And I already said, I gave you that the huge study on Mississippi. And I've already said, hey, listen, don't give up on foundational skills. So here we are in sixth grade. I want to know not just how well they're doing in the multiplication, I want to know how is that impacting them in core. So you're actually starting to see near measures, the intervention, and far measures, the core. Is the intervention moving the core? Because a lot of our interventions in math will move them in a skill, but that skill alone is not impacting core enough. That's where we win. All right, what does this have to do with this all? Right. So your guess is you guys actually were really good. Maybe I couldn't distract you enough. So the distraction, you got it. We had biology and we had kind of the external, the shell, the skin, right, which is right, large organs. We've had this over and over again. Everything was outer shell, even the cushions. Then we have something that wasn't like the others. We actually started broad and then we started to focus on the similar items, right? Biology and then external. And then boom, we went back. What does this have to do with math assessment? Have you ever looked at this? You got it. You know what we're doing next, Andrea. So have you ever worked with students and you start seeing a pattern? And you're working with students or you're grading their papers and you start seeing a pattern. And then you start anticipating that pattern. Math assessment is about anticipating the pattern. However, I'm going to give a caution before I dive in too deep because we don't do a lot of error pattern analysis on today because of time, but be cautious. Be cautious and ask questions. If you don't know exactly why the student's doing what they're doing, you must ask questions because just because we see this pattern and the variance may be that very few students vary from that error pattern, we still need to determine why they're doing what they're doing. So when I dive into it, I think Andrea just set me up for this one. How is math assessment like an iceberg? If we were live, we'd have lots of conversations, right? Getting your groups and all that. But the bottom line is, I think we've already started this. When you assess, you're seeing what's above the water. If we only look at answers, and we don't get into the depth, the how, the why, we're not getting below the surface. We're not determining what's driving what's above the water. So we get stuck on saying, oh, this child can't, and let's work down the grade levels. This child cannot use elimination for systems of equations. The student cannot factor a quadratic. The student cannot perform factorials. The student cannot, right? And so it goes on and on that way. I hope you're not losing audio, by the way. Keep checking your audio. So keep the chat, guys. Thank you for working with each other. But when we're going through this and we're really working to find out. Yes, see, I'm with you, Emily. We've got to find out where the error is coming from. So today we are going to dive into that because when I work in this, let's say it's solid fate, right? Solid air, excuse me, backward speaking, surface area of a solid. Why might they struggle with surface area of a solid? Maybe they didn't know the formula, right? And we might find ourselves, why give them the formula to eliminate that? But then they still have errors. Well, that's because they struggle with substitution. Why do they struggle with substitution? Maybe it's calculations. Maybe it's this distributive property, right? What if we're doing addition of fractions? Because fractions is a very low achievement area for our country. In this case, there are several reasons why that might happen. If it's adding fractions with unlike denominators, what if they don't understand what a denominator even is, right? Number over a number, it's a horrible representation of a point on a number line. So therefore, that numerator denominator may be confusing. Why? Well, they don't understand place value, right? The denominator's operationalization. They might understand place value. Why not? They lack number sense, or they're counting from one, right? Kids who struggle with fractions, they think that one is where you start counting rather than from 0, 1. They don't recognize there are numbers between 0 and 1. But don't get down that one string. It might be something else. What if they can't simply calculate least common multiple? Well, why not? They lack, proficiency in multiplication because they never understood multiples in the first place. Excuse me. These are lines of data we have to start getting through. Now, some of you have screeners. We'll talk about that in a second. And your screener actually does a task analysis. It is guessing where the error pattern is coming from. Don't take that for the word of right, the big guy. It is not that specific. We have to dive in more. So here's what we're doing today. When we're talking about our students, we're going to talk about this cycle of instruction to intervention. We're going to start with determining the outcome. What is the expectation? What is the level of complexity that you're looking for? Then task analyze. We're going to task analyze. I'm covering Jate's awesome work. We're going to task analyze what it is of how to solve that problem based on what you're teaching. Then we're going to align students' needs per step. We're going to teach and assess them, analyze student performance, and based on that performance, you got it, determine what we need to do next. And that cycle continues. I would love it as a cycle. So we're going to tackle it in this manner. So let's start with, well, we're going to look at 3 different ones. Screeners, touch on diagnostics, but progress monitoring, we don't have the time to spend a ton on diagnostics and progress monitoring. So let's talk about those screeners, and then what can we do to dive in further. So when you're looking at screening data, when you use a screener, you might create your own screener. I'm not going to advise that today. We have not had great success with building our own screeners in there, just so you know, particularly our secondary folks, right? In fact, there's very little out there to grab, but we have to know what their strengths are. That is not just an assets-based thing. That's based on that TIM study I gave earlier, because we need to show students what they're competent at. They need to know what is working, because if all they hear is you didn't get it right, they're going to start thinking, I can't do math. They're going to think all of math is about that answer, rather than math is a proof. And I know I said that quickly, so one more time. Math is a proof. We need to teach them. There are multiple steps. Each step has reasoning. And if you skip one, that doesn't mean the end of the world. That means we need to focus here. And that's what we need to talk about. So show them what they can do right. Then what are the needs? There are academic needs and behavior needs. And as we know, sometimes they're not touching, but most of the time, academic and behavioral needs are connected. There are fewer students with behavioral problems who are great at academics than poor at academics. Most of the time, our behavior problems are related to that. Now, we all have our exceptions. We've all taught them, and we probably all love that kid because they're so different from what we're used to. But most of the time, academic and behavior are connected. So then we need to focus on what can we do to immediately support them at the core and to support the intervention. See, excuse me. Hold on. There we go. So let's talk about two different students here. This is some data that I pulled. We're protecting the names for the innocent, and you don't know where I got them from anyway, even if I had a cute name in there. But this is a seventh grade student. We ran a screener on them. I'm not celebrating the screener. I'm not saying this is the best screener, but I do want you to know good screeners will give you some better information. Oopsies, trying to see what you wrote here. Click, click, click. If we teach early elementary, do we recommend this? I actually do recommend a screener for early elementary because everything kids walk in even to kindergarten with past information that is expected. We are competing internationally against a world of preschool. So yes, we have preschools across the world. We don't have set preschool. Now, and the data is pretty clear on that. You can go check that. But we need to set this early. Where are the gaps and clean them up early? The earlier you catch those gaps and fill in those gaps, the better trajectory that student has in mathematics. I did not do the trajectory in math today. No one's asked me to, but you can take a look at the compressibility of math. Most of the hardcore math is K3. That is the foundational area. And from there, the arithmetic to algebra gap begins, right? We've got to have that built. But let's take a look at student A here. In student A, we got a scale score, percent rank. All this is good information as my assessment geeks. You can see what your students are doing overall and where your student aligns with where they are today and what is the projected growth of how well they'll do by the end of the year. So take a look. Measurement, this is just cuts a little bits from student A. No recommendations for measurement and data, but take a look. For a seventh grade student, there are two fifth grade skills that need. Stop. That doesn't mean student A only needs that. You have to now find out, are there precursors to fluency, to division that student A is going to need, right? And can I do that at the same time I'm teaching fluency? Same, multiplying a fraction by a fraction. Listen, multiplication of fractions by a fraction is usually not a typical error pattern unless they struggle with single digit multiplication. But you can see this multiplication is coming up repeatedly and division, which is related. So we're starting to see student A's needs of how that's impacting them in the seventh grade. Let's look at student B. A little more complex here with student B. Student B is needing more intensive intervention than student A, right? They are in the red. And this color code's not all screeners color code, but they should give you an impression of what the need is. But take a look. Addition, subtraction, the application of addition, subtraction, and yes, measurements included as well. Geometry. Now we're starting to get visuospatial issues are starting to show up in there too. I'm trying to read these as we work through. So yeah, this is Renaissance Star, seventh grade screening. And that doesn't mean I'm not recommending. I'm simply just using this as a model to be consistent. But again, you can take a look here at student B and see we have higher needs in this case. So let's stop for a second, take a look at this data, and I want you to determine what would you do to start supporting student A and what would you do to start supporting student B. I'm not asking about core content at this point because we don't know where they are in the curriculum. This is a summer. Otherwise, I'd like to say, here's what we're doing right now in seventh grade. I'm not going to play the game because that's a very complex thing that we'd have to problem solve together. However, taking a look at this data, what do you think is the next intervention you would start? So I'm going to stop, zip my lip for a minute, and let you guys type. Jen, you rock. So far, we got one saying we have basic fact struggles. Any others? And you can specify in your answer, student A, student B. There we go, Chandra. Thank you. Right. So Chandra's going in there immediately. Student A, that is a focus one. We look at that attempt at error pattern analysis from the screener, and it says immediately multiplication division. See, I'm with you. I would even look back at that. The next person out there, I think it's Groner. I might be messing up your name. I apologize. But yes, I would start looking, going, okay, if we got some multi-digit computation as well, maybe place value. We need to dive in further. I would do something further. Oh, you know what I'm going to do next. All right, great. Okay, here we go. Chandra's also saying, look at addition and subtraction facts. I'd probably start with that and then look at the applications thereof. Yep, multiplication facts, basic facts, on and on. I'm just going to give about maybe 10 more seconds to type out if you see something different that you would like to talk about. We see place value definitely in student B. Student A, yep. We got measurement data. Yep, place value, start taking a look at that one. Student A and B, check with place value in the big relationships. Okay. There we go, Diane. We need a diagnostic to one, to determine if this is close. And two, we need a diagnostic approach to determine if this is close. Where do we drill down? Where do we start? Now, you don't always have to start on the bottom rung. You can actually start up a little higher than that and see if we can support this as we're going this through. Don't always reach down to the very bottom. But a friend of mine explains this well. She explains, principal, who I love dearly, says, look at math as a Jenga tower. It is not stair steps, it's a Jenga tower. And you are adding in grade levels up top while you're filling in the interventions down below. Because if that foundation is weak, that Jenga tower, as you keep going, is going to start to sway in the breeze. So we have got to fill in the intervention, and it isn't easy. It is harder to fill in the intervention than going on top. Core instruction is where we should lean our information on this one. You got it. And Jen, I'm with you on that too. All right, so here we go. Let's start talking about a diagnostic approach to us. What is a diagnostic? Now, you can purchase a diagnostic, or you can go into, sorry, Diane, I just saw the happy clicker comment. Or you can build a diagnostic that is based on our classroom information. I'm going to lean on choice B. So let's take a look at this first one here. NCTM, and I should be good, NCTM has said, and I know a lot of times people think NCTM is anti-algorithm. They're not anti-algorithm. They're anti-mindless steps. And for that, I think we all agree, right? Don't do mindless steps. They're actually pro-algorithm because algorithms have meaning. Every step has a meaning. Every step has a meaning. That is an algorithm. Mindless computation steps, that's a whole other thing that we're not even going to address. That's just bad instruction. But take a look. When students are faced with multi-step problems, they tend just to randomly compute. They don't know how to tackle a problem step by step. So what does that mean for us? We'll be building task analysis and differentiation. So in our task analysis, we're going to determine where, if I'm solving blank problem, we're a lot of different grade levels out there, whatever problem we're solving, I'm going to break down the steps of how I'm going to do that. And then I'm going to go in there and I'm going to work with students to determine where they are in this process. There's a way to do this and get an error pattern analysis out of that. So let's dive into this. Task analysis, big idea, broken down into steps. In math, every step has reasoning. That is a very big deal here again. Don't get caught up in thinking that there aren't others. Now, and so I just saw the chat. That might be part of your task analysis. Read and understand the word problem. That's why mnemonics or acrostics or heuristics are always involved with word problems. All right, task analysis. Here's the outcomes we've learned. It reduces error, simplifies complex teaching, complex information. And that third one allows us to teach and reteach, allows us to know what we're doing. So these are some approaches to task analysis. And if you're not a task analysis fan, you're just going to have to go do data on this one. Take a look at Hattie or some other person that kind of looks globally out there and see the massive, greater than one effect size, greater than a standard deviation. That's all effect size is. Greater than a standard deviation. Task analysis always stands out. Connected to mnemonic, even further. So task analysis, big idea, broken down into steps. This one is addition of two add-ins. So one, determine, come on, big guy. There it is. Determine if the problem's addition. So identify the sign. We have learned that signs, equal signs particularly, are troublesome to some students. So make the student identify the sign. I for identify the first add-in. In this case, it's two. Go to that number on the number line from 0, 1, 2, maybe, or maybe they just know where two is. Wouldn't that be nice? Then identify the second add-in, 5. Take that many steps forward from two. Don't start counting one here. From two, 1, 2, 3, 4, 5, and they are end up at 7. You got it. Say the number where you arrive. 2 plus 5 equals 7, or right is the same value as 7. That is a task analysis, and we made a mnemonic out of that because of digits. Digits looks and similar to the approach. There's some other ones, task analyses that you might have created over time. This one I did with a team at a small rural school where we're trying to change their computation of multi-digit numbers to place value. So the mnemonic was 47 plus 28. I love place value language. My friends who know me well know I speak differently with my own students, my own children, and when I teach. 4 tens, 7 ones plus 2 tens, 8 ones. So I need them to decompose the add-ins. Then, so I decompose 4 10 7 ones, 2 10s, 8 ones, right? And I'm adding, make sure you put your addition sign for all. It's the distributive property. Let's do it. All right, one, compute the tens. 4 tens plus 2 tens is 6 tens. Compute the ones. 7 ones plus 8 ones is 15 ones, or 1 10 5 ones. All right, now total the sums. 6 tens plus 1 10 is 7 tens. 0 ones plus 5 ones is 5 ones. The answer, 7 tens, 5 ones, right? So DCC or DTOS, I've tried this so many times, it doesn't look good. Thankfully, a teacher with a little more sharpness came along and she said, I can actually make that into an acrostic. I can make it go out to total, take apart the add-ins. I kind of like the word decompose, I understand though, but she goes to, I'm taking apart the add-ins, orient by place value, total from large to small. I think it's from greater to less. That's okay. Assess the sum, list the answer. Now, I'm a mnemonics guy in this case. I kind of like the mnemonic. I want that place value language built in, but I fully understand that she was having a hard time getting students to follow the steps correctly, memorize those steps. So she built an acrostic off of it. Between the language, we could build that acrostic. I know you're out there and you're going, I would take some good math terminology and put them into that acrostic. I like where you're thinking. But that is the difference between a mnemonic, DTOS, doesn't stand for anything, versus an acrostic, total. And the total in this point stands for what we're doing specifically in that problem. Now, we haven't even gotten to the assessment yet. So just so we're on the same page, there's a lot of acrostics, mnemonics that are out there in the system. If my high school friends out there, high school, right? If you're working together, we tend to do this. We look these up, we look for them, or we build them. These are ones I built. But solving equations, I have my 8-step, excuse me, my 7-step approach there. I have slope intercept for 7-step approach there. And I've got my 6 steps, which has one step needs to be broken into 2, but is factoring for factor the quadratic. But anybody else, right? You build your own mnemonics throughout. You don't build them for everything, but big ideas that need to be recalled more quickly, right? When you listen to Paul earlier on the maintenance schedules we have to do, mnemonics help retrieve information. So this is part of that process. All right, here's your turn. We're gonna have, I want you to build, right? Me and my Scranton friend want you to build a mnemonic or simply just a task analysis of a math skill that you find your students may not do as well in. So let's just take, I know I'm not going to give you enough time for this because I want to show you the assessment on it, but I'm going to zip my lip for about maybe, let's say about 2 to 3 minutes, write out a task analysis of a hard skill, and then build that. If you can build that into a mnemonic, great. If not, it's okay. Just give me the task analysis. One way you may need to do that is to have a sample problem. Think of a complex problem that you know your students would have a difficult time learning. Check to make sure your steps actually show what's happening in that problem and why. Okay, I'll zip my lip, answer some chats, and we'll go from there. All right, I'm just gonna answer you back. I'm going to answer your chat so I don't interrupt some people just by writing. You know, mine, sadly, just about another minute in there. Amy, zip, I said to be quiet. Eat you guys. If you're done and you have questions already, just pop them in. And because we're about maybe 15 seconds out from, I want to show you what to do with that task analysis. Okay. So you've written out your task analysis, some funnier than others, but remember, every single time you develop, hold on, I'm going to address that, Jen. That was awesome. Every time you develop a task analysis, just make sure those steps, even if they're funny to remember, connect them to reasoning. So even if it's, you know, the monkeys thing, then connect that back to what exactly is happening and why it's happening. Like for long division, if it's 15 into 182, it's not 15 into 18. It's how many groups of 15 go into 180. Just make sure we're clear on that. Oh, Andrea. Did you just do that on your own, Andrea? Again, you math people are just amazing. Andrea, that's why I love your big brain. You got to keep helping me. Okay, let's grab that task analysis chat GPT. I knew you to write something like that, you turkey. All right. Oh, by the way, yeah, let me stop there. A lot of the mnemonics and acrostics I'm starting to see come from Brisk or ChatGPT or Gemini or whatever is out there. Now, if you're using an AI program on that to do that, just remember that you need to go back and really clean up what's going on there. For example, you have a great terminology mixed into this. Ask the AI program to use accurate math terminology in its mnemonic, just so you know. All right, so let's take that and I'm going to build on that. So I had an addition problem earlier. We had place value. We had to do grouping first, decompose by place value. Then it was adding greatest to least, right? From left to right, typically, but I want greatest to least. Now, this is how that would look on an assessment. So I'm going to reduce it here. Now, let me show you what this is. All right, first, I love a little humor. Does anybody know my group of students? Just give you 10 seconds on there. Oh, Melissa, I promise I'll be back to serious in a second, but someone's got to know my group of students. Who are the students in this classroom? Someone's got to be old like me with a good sense of humor. Let's go. That's right. Oh my gosh, you guys are killing it. Thank you. There you go. Trillium, thank you. There you go. Okay, McCarroll, thank you. Right? WKRP in Cincinnati. Okay, awesome show. All right, now I can reduce my chat and get back to it. All right, so Mr. Carlton, yeah, Jennifer Marlowe might be the only student on there. I gave her He needs his help. But Jennifer will be the only one who gets everything correct. But take a look at how we set this up, because one of the questions in there, I'm going to go back up, Melissa, we put the mnemonics on the assessment to see. Yes, absolutely. So take a look. These are key features in there. So you take your mnemonics. I take them by key features of the mnemonic, not just that they memorize the steps. I want to know the reasoning behind those steps as well. So take a look at my expanded or decomposition. I have in my top row here, right? My top x-axis. Students are here, and then my steps. Now, my steps have reasoning. Never do blind steps like multiply the fraction, flip the sign, invert the fraction. No, I've done nothing like that. I want it to make sense and be reasonable. So when I ask a student why, if they have an error, why did you do this? I don't want to hear because that's what you told me to. I want to hear a math answer. So take a look here. Expanded by place value or decomposed by place value. Then compute. In this case, it was tens and ones, but it was greatest and to least. And I want place value answers. Then sum those, right? Sum the totals, the subtotals, and then is your answer correct? When I look over my students' data, and there's another column I'll explain in a second, but when I look over my students' answers, look, it looks like half of the WKRP crew didn't get the answer right. And a lot of kids think that that's math. I'm just not good at math because I can't get the answer right. That's not it at all. We actually want to go back in and find out where they did correct versus incorrect. So take a look. Big guy, Mr. Carlton, when big guy did it, he has his answer wrong. But we can look back through and show by doing the grading this way, he didn't compute his ones correctly. Now remember, that means based on that error, he summed that error correctly. So I'm not going to make it this wrong as well. I'm going to make sure I stop with where the error is. Okay, he did that step incorrectly, but is he summing the tens and ones correctly? Yes, he did based on his answer here. But the answer is incorrect because of that one step. This allows me to give direct feedback to Mr. Carlton first. Wow, you've got one of the hardest things done here. I appreciate you got place value and even computed with place value. Think how hard that was, because these are real students just with pseudonyms on them. But you computed the ones correct. Excuse me, you did not compute the ones correctly. That's what led to this answer. But you did some of the hardest steps here. Now, for students who get it right, the kid who goes, I did it in my head, that is fine when the working memory matches the number of steps that I'm teaching. But when I start teaching beyond their working memory, this is the arithmetic to algebra gap, right? I start teaching 8-step approaches and then he can't do it in his head anymore. So I'm not here to make it onerous on the students, but I tell them when it's time for whiteboard work. Ooh, I think I fuzzed out my screen. Let's see if it works. Okay. So if you're a whiteboard work, oh, it's kind of there. I actually go, okay, show me step number 1. So they write down step 1, 2 ends on board, board to forehead, and I'm up here with a checklist. Who's got it? Who's got it? And it's funny, they'll be like, oh, Witzel, I didn't do that step right. No, 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 you're fine. I think you're actually on the right track. They'll start to see how this assessment works because I give them feedback of what they're doing correctly first, right? So it may be wrong here, but the next step. In other words, they'll go, now it doesn't match. You're actually back on track. Keep going. You're back on track. But my number doesn't look right because of the first step. Let it go, right? Because they're looking at each other's work, like all kids. But quick whiteboard work, unless you do small group or you're a station teaching lover, that's another way to do this. But you check them step by step. Now, think of my students who really struggle, like Johnny Fever, which would make sense for the show. Johnny Fever, place value and tens. Both of these are errors, which means that impacts the answer incorrectly. But that means I know where I'm focusing my intervention. For him, he needs place value and tens. In fact, I've got a group of 3 students right here who have some place value concerns. Does that make sense? All right. Now, how do I score this? Take a look here. Actually, I got 2 out of 4. That should be 2 out of 5. My guess is the teacher probably had, I probably erased it. They probably had a differentiation in here that they supported the student at. But you give them the points. This case, 2 out of 5, 5 out of 5, 2 out of 5. They 2 out of 5 steps correct. 4 out of 4 in this case. This is my guess is this teacher probably didn't mark this wrong. She probably already did a differentiation for Venus in there. But again, 3 out of 5, and again, 5 out of 5. You're giving feedback of how many steps they got it correct. Now I'm giving you a hint by these scores. See how they didn't match up? Oh, guess what? We're about to go into differentiation. But take a look at how the assessment works. Let's do one more example, and then I want some feedback on this assessment type. Then we're going to start diving into how do you set up differentiation. Here's another one. I taught fractions. Oh, I know what's happening. It's me versus Google because the spacings are on. So I'm teaching fractions, and I set up fractions maybe a little differently than you're used to. I don't, if I can't explain invert and multiply, which is based on the identity property and adding fractions with unlike denominators, I can do that. However, this case, I'm going to teach you a different approach to it. It is 2/3 divided by 1/6. So I have fract, fine, right? Focus. Are the denominators the same? They are not equal, 3 and 6. So no, rewrite equivalent fractions to make the denominators equal. All right, so 2/3 is an equivalent fraction to 4/6. So now, do I have sixths in my denominator? Yes, ask yourself, do the denominators divide to be 1, right? 6 divided by 6 is 1. Listen, you multiply across, you can learn to divide across. Now here, look, calculate the numerator. Okay, if 6 divided by 6 is 1, what's 4 divided by 1? It's 4. Listen, if this was 3 divided by 4, it would be 3/4, right? So it's my numerators. 4 divided by 1 is 4. So it's 4 divided by 1. My answer is 4. There are 4/6, 1/6 that go into 2/3. So those are my steps. Those are my 5 steps to division of fractions. Now let's put that to an assessment. 1, checking if the denominators are equal. Another step, rewriting equivalent fractions, and then that should automatically compute. If that's done correctly, they should get 1. My expectation is we can do identity, right? A number divided by itself is 1. And then can I calculate the numerator correctly? So here's my students. These are former students of mine, not in the same class. So, right, I just wanted A, B, C, D, E, F, and I wanted to fit it on sheet. I do have fully worked ones. I have teachers who do this with 20. I taught a class of 52. You can do this. If this looks overwhelming, break them up by stations and assess them in small groups. But take a look at the data here. Oopsies, oopsies, oopsies. I didn't do my data. Okay, because it looks like I'm transitioning. I apologize. But take a look at the format here. I'm about to give Abigail feedback of whether or not her answer is correct and why. I'm about to tell Carl if the answer is correct and why. And if Devon has an error here, I can even point out where it is. So let's stop and let's reflect, and your turn to develop. So for you, set up your formative assessment checklist. List your steps. If you need to have okay, but I actually have a grid here that I create, and it is simply just the same sheet that you just saw, just blank. You start now just on a piece of paper, set up your x-axis, list your students on that far left y-axis. Then you'll collect data by steps, and we're going to start to talk about differentiation. So those are the steps to doing this. That is what I want you to start thinking how to do. But before we go on, let's do a stop and check. For whom is this a great approach of giving feedback? Look at you, Jen. Oh, I just caught that, Jen. Okay, but for us, right? So for us, for whom would this be helpful? What are some benefits of this assessment approach, this formative diagnostic approach? I love it, students and teachers. There, teachers, right? Yeah, let's get specific now. I should have asked that more specifically. That's on me. So yes, teachers, we get to plan next steps. I get to find out where my lesson fell apart and where it was strong. Good. Give me some other thoughts here. What are some positives of this approach? The negatives are obvious. People are going to say, man, that's a lot of time. If you're not organized in that, yes. After a while, it gets quick. But what's another potential success with this assessment approach? I'll give you a couple minutes. Let's do a full minute on that. Love it, Aaron. Jen, yeah, we need to chat a different time if you don't mind, Jen, because that's more specific of which ones match up to your needs. Um, you can always go intensiveintervention.org if you're looking for specific screeners and what the data says on different screeners. Okay. Okay, let's go back to Angela. So Angela, right, we get to know their problem areas, where they need help in specifically. Positive reinforcement. Devon, you were on the same page. Instead of me just saying the answer is right, the answer is wrong, I get to dive into what they're doing correctly. I can have a student in an 8 steps. He gets 1 step correct. That is where I'm going to start. Look at that. You started the problem on the right step. I now need to teach you only 2 steps at a time. because he can eat, it probably was too many steps at a time to memorize. This just in, Piaget 7 has never been replicated in research. 3 steps at a time is the average working memory of an adult. So if you can only do 3 steps at a time, think about these multi-step approaches we teach. Don't teach beyond 3, even for our higher performers. All right. I can group on strengths, areas of deficits, limit. I can target what they need. I can give that feedback to moms and dads. Think about that, guys. So when mom comes in and says, I don't know, this is the new math, right? The first cartoon, I can't help. I can now give them feedback exactly what they can do at home. You're teaching quadratics. I can't help with that. Actually, you can. I need him to learn on what are the different factors of whole numbers, right? Just whole numbers. You can help that at home and then show how that fits in a quadratic. I can even write that out so mom knows that's all he needs. Well, there's another thing, but that will get him started, right? We can work together on it. Yes, the confidence. Brenda, you remember I threw the Tim study out there because I said we want to give them feedback of what's working. This is an assessment that gives that child feedback of what's working. Tells mom and dad who might be saying, it's okay, sweetie. I can't subtract either, right? Instead of that insanity, I actually give them feedback of what they can do at home to give support. Let me read some other ones in here. Yep, and best use of instructional time. It can be quick if you learn how to do this efficiently. Breaking it down. Yep, no, there you go. Devon, we're on the same page. We got to meet. We got to meet. Consistent with scoring. Yes, this is based on the old mastery grading. But when people didn't know what to do with mastery grading, I said stop giving them tests and giving the answer. Mastery grading means understanding the mathematical approach, right? And anybody who's anti-algorithm, someone has fed you bad information. I'll give you, for example, my oldest daughter is a biomathematician. Her entire world is building an algorithm to determine biological functions. Algorithms are math. Don't be anti-algorithm. You can be anti-blind procedure, but don't be anti-algorithm. They're different. All right, ELA. Okay, well, say we still need to chat. Yeah, you guys keep tagging on that because I cannot help a student who likes things to do in their head. Yep, but this is where we go. Stop. I need this one done on paper. I can't assess you because what I'll do is I'll write on their sheet, Katie, NA. No attempt, no attempt, no attempt, correct answer. And then mom and dad are gonna have to meet with me of why he gets 1 out of 5 points, right? And they go, well, wait, but he can do it in his head. How dare you do that? No, no, no. And then I get to explain working memory. That right now, when I say do it in your head, he can do that. But when I say show me your work and he can't show me the work, that's where the mathematics falls apart. All right. So yes, so good, Jen. So if you still have mastery grading, you know where this goes. All right, so let's tackle the next step. Let's look over our students' needs. So I'm going to minimize my chat and let's go. Here's our next step to this. This is an intervention group because I don't want to have 20 kids interventions there. That's just wild. But you ever have this before? Like we have 13 kids in a class of 30 who are on IEPs. And you're like, how do I differentiate for all of them? And we find ourselves kind of doing the UDL thing, which means there's some positives, but it's not targeted intervention or targeted support. UDL is kind of gross universal. GROSS universal. It's not yucky either. All right, but take a look at my students for that division of fractions here. 3 of my students struggle with computation, right? B, C, and D. 1 student likes all computational accuracy, and Abigail never would have. God love her. She was amazing. She became a professor later. But Abigail was lacking computation. And then 2 of my students didn't understand fractions. So we have a conceptual problem. So start to chart your students' needs. If you have students on IEPs or 504 plans, IEPs and 504 plans, chart them out of what you're doing with your students, right? So in this case, I've got 2 students struggling with fractions, and I said I had 3 basic overall students who had different areas, but they all revolved around multiplication. And yes, I will show you what this differentiation accommodation is, right? Calculators don't have great research support on them, and another day, another time. So I have to have something alternative, and I'll explain. This is my formative assessment. Remember how I said that the scores don't all add up? It's because it probably was a copy of this. This is what was the assessment. Before I even assess the students, I am writing in what I'm going to do for them. Here's my color chart. It is dependent on me. Bright red means their work will be dependent on me. I am giving Carl supported visuals to help with equivalent fractions. Basically, I'm doing the equivalent fraction for him at the visual level. So this is my reteaching. Oopsies, hold on. This is my reteaching. Teacher review means Abigail's going to do it, but I have to come over and check on Abigail's work. I say that's transitional because I'm trying to fade the accommodation. How many times do we have an accommodation for a kid, and that is now their accommodation for the rest of your life? This is not an accommodation. These are modifications. If you are given a accommodation that never goes away, that is not an accommodation. That is a modification if it alters the standard. Therefore, we want to track that use. And I want to make it as independent as possible. If not, I want them not to even have support. That would be the ideal, to fade the supports until they are ready to be independent. Sometimes that's not going to happen. So I'll show the multiplication in a second. But when I'm doing the same thing, this is not color coded. If you're just trying to get your feet wet, you're like, bam, Brad, I ain't going to color code everything. I'm good. Get your feet wet. What are you going to do for that? This is the equivalent fractions, compute the numerators and denominators for this. This is the same fractions approach, but for the A team. So when I'm teaching the A team, I've got teacher checks and I've got that multiplication chart again. So when I'm looking over their work, this might be how I grade. See, if they're not looking up the multiplication, it's one. Now, if teacher checked me, they did the work and I checked them off, I'm going to give them credit. I'm going to write this in green and still give them checks because they did the work. I just have to check it. But I'm still writing in that I'm doing more work for them. But take a look at how this ends up coming out. Remember I said the numbers didn't add up? Here we go. So bad attitude Baracus, right? He had 2 steps correct, which I'm going to emphasize, but he didn't simplify the answer, which led to an error in the answer. Listen, if it's calling for a simplified answer, you got to stick to that. Don't back off and say, I'll reduce rigor for him. Do not reduce rigor. Keep it and give him the feedback going, you know what? You're on the right track. We just got to learn how to simplify that fraction, whatever simplify means these days, right? 2 forces, the equivalent fraction at a smaller numbers. I'm not sure why we do that all the time. Okay, focus, Brad. Faceman needs all the help he can get. Remember he was a schmoozer? Ooh, so yeah, he did 1 step. He simplified the fraction. We basically did all the steps for him. He had to check on the list and follow the steps, so we gave it to him, but then he had to do 1 step, and he did it. I'm going to celebrate him, and then I need to start fading his supports. Teacher check would be my first one. All right, Hannibal. Hannibal made 1 error, same support, but look, he gets 1 out of 3 because I have to look, what am I doing for Hannibal to set up that equivalent fraction? And then Murdoch, crazy fool, he got them all correct. And I don't remember Tanya in the A team, but so I just gave Tanya all correct. But Santana, wasn't that the general? 1 step incorrect led to this error. Now I can give targeted feedback and I can start charting and keeping track of how I differentiate and how the differentiation is supporting their learning. So when anybody ever comes and says, what are you doing for Murdoch? I can say absolutely nothing. We have faded those accommodations and Murdoch is succeeding. Santana, what are you doing? You know what? We need to start looking back at Santana. Are we seeing this repeatedly across other math constructs? Yes, we're seeing computational errors. Let's start looking at what we can do to support Santana. While Santana is receiving intervention, he needs to get something that will support him in core. That's this multiplication chart. Okay, look over what we're giving them. Take a look at what we're doing so we know where to focus things. I've got 4 students receiving intervention here. That is important. This is that support while they are receiving intervention. Once the intervention near measure shows success, I want to start fading this so that we can start seeing how that will impact them in the core program. All right, so your turn. Think about your students' differentiation. Then I'm going to I know we only have about 10 minutes technically before we do Q&A. I'm going to dive into what we can do and some supports for them. And that is going to be a quick. Just want to help you understand that after this is kind of the assessment. Now, what do we do about it? So I'm going to back off for a minute, give you a minute to start looking over, thinking about your students. I know you're going to summer. Some of you still are doing summer school. What are my students' needs? How would they be impacted on your task analysis you did earlier? What supports would you give them? And then what are some benefits? This last question here, this is the one. Let's keep writing those in. We want to support each other in doing this. Okay, so I'm going to back off. Let's do 2 minutes on the timer. And then We'll get back together and finish this up. Right, you're right now, Jen. Are you tracking what time? Sorry, guys, just about maybe 35 seconds left. I'm just answering email or answering the chat as quickly as I can. By magic, Emily. Um, okay, so my time, our 2 minutes are up. I hope that you're finding this. I'm answering as best I can with this. So yes, exit slips are great. Um, but we need to get data done. You can do this. Oh, there you go, Jen. You can do this digitally. There are some programs out there that allow that digital component to work. There are also AI programs that can go out there and analyze it. If you write in your task analysis, they can support how to do an investigation of your students' work one step at a time. Um, I saw this up front. I wanted to address it. How do I manage all this with 77 students? Well, if you're teaching 77 students in a large lecture hall, I taught 52, 77 beats me. I would break them in. We have 12 round tables, 4 to 5 people per table. You could do that with 4 or 5 people at a time. As you get more adept, let's say a more manageable class size, 20, 25, you'll start to notice when I've got my sheet, I'll just get my clipboard here, although I did blur the background, which was silly of me. As I'm going through, if I did this correctly, I will go through and go, who's got wrong answers? So just to be fast, I'm not checking correct. I'm going, who's got wrong? One wrong, two wrong. But if I see out of, let's say I got a group of 20 and I notice that I start scanning and immediately I go 5 or 6 are wrong. I will say, stop, pens down. I see even the first steps. First couple steps, we're starting to have trouble, guys. Let's talk through this. It is going to stop me in a formative manner. I'm not just going to force the assessment on them. If I'm seeing repeated errors across my class and the same step, that's on me. I'm going to refocus my instruction immediately on that. Some extra practice based on exit slips. Yep. Close gaps. And there we go. All right, so let's tackle this and do our next step. Hold on. I'm trying to read all these at the same time. Yeah, and Devon, I want to take you to the, is it Devon or Devon? I apologize. But I want to take you to the next step on this. It might be that we have different students with different background knowledges. So you'd have to know where those potential errors would be. Some people don't like this approach because they say there is not one way to do this. Now, I get that. Our new textbooks are crazy. They say to do like 25 ways to do multiplication. There is no research support for 25 ways. We need a core way to do mathematics at the foundational level that we can build on. And stop calling these alternate approaches. They are based on the same mathematical principles when you show this approach versus this approach. They are mathematically connected. We've got to force our students to understand relational thinking rather than just divergent thinking. Drawbacks is, I'm trying to read all this. Okay, I got the benefits in here, drawbacks. Yep, you're all with this. And pre-made checklist. So yes, there are pre-made checklists. Typically when you look over, not checklist per checklist, typically when we look back over our standards, you'll see what they're emphasizing. If they emphasize place value, you know to put that in there. All right, let me tackle this next part. I want to show you, oopsie, sorry. I'm going to show you what we can do with this. Here's some of the accommodations that I mentioned briefly. I've got about maybe 5 or 6 minutes. I want to go through. It's a speed one, but I want to show you what we can do for students in different error patterns. I'm doing this knowing that I know in the afternoon I'm covering intervention, but I'm covering only secondary intervention in the afternoon. Therefore, I want to give some extra ideas. You got great speakers who are going to give other ideas, but I want to make sure I share those ahead of time. One, this is a faded hundreds chart. I call it a hundreds table combination. Once again, faded hundreds chart. What is a faded hundreds chart? Well, you give them the hundreds table, the multiplication table. When you ask students to do this, they go, okay, 5 times 5 is 25. Even if he knows the answer, he's going to look it up. This is the same thing as a calculator, but I can't program a calculator to not give them calculations they already know. I mean, I worked with a student once who had 9x plus 1x, and he goes, 9 groups of x plus 1 group of x. I go, yeah, so how many groups of x? Oh, it's addition. He pulls out his calculator, 9 plus 1. He can do 9 plus 1, but he's become so calculator dependent, he won't believe in his own work. So this is a faded hundreds chart. The first time we do this, it's all the facts. As I am teaching the student and they're gaining efficiency and proficiency with their work, I start to put stickers over the ones that they know. They received, so this child can do ones and tens, they should cover the ones and tens. He cannot look up ones and tens anymore without peeling the sticker off of it. Then he learns the fives. Once he learns his fives, I make him cover all the fives. Good job, you nailed it. It's sticker time. Cover those fives up. And we're covering the fives up so he can't look them up. As he's going through, he learns facts bit by bit. So instead, like he's going, okay, 8 times 8 is, oh, I think it's 64. Let me check. Oh, it's not even there. Well, what is it? It's 64. If he is right, you put it on. If he starts getting it wrong, who knows why? Just that retention of knowledge piece. We need to help him with maintenance, retention, and then put the sticker back on. Take it off, put it back on, or give him a new chart. But this is a faded hundreds chart. We are working with a student so he can only look up the facts that they have not mastered. All right, let me give you another one here. Partially worked problems. I've been told that a lot of times, well, he can't do this. He can't do any of the prerequisite skills. Well, I'm like, well, maybe that's not the point of mathematics. Maybe my point of mathematics is I want him to explain what's going on and break it down for me. So here's the example. Frank struggles with multiplication. So he's having trouble applying the distributive property. I know it's secondary, guys. If you're not a secondary person, you're like 3x times what? Just relax. You'll see where this goes. So I want him to calculate that expression. So here's a partially worked problem for Frank. I would set up how the distributive property would work. He would have to put in what goes in here, positive 4x, positive 5y, negative 6. Then we can do the next step. But this is where I set him up. I do partially worked steps so he can do this. You might do this across problems where instead of asking the whole problem, do it all, you say just do step A. Then once he does this, oh yeah, this is me versus Google. It's all over the place. Then it's step B and C. Then it's D, E, and F, and I give the answer to it, right? You can support that student by giving them small faded support, right? You fade your support and make them more independent as time goes on. So you take this from my turn. I'll show you how. Now you teach the student that first step, and you can do multiple problems practicing just the first step. Then you do multiple problems practicing the first 2 steps. Then you do multiple problems practicing all 3 of these steps in there. The purpose of this, again, is to fade your support. So you're not just saying, I showed you how to do it, now do 20 on your own, or talk through it with me, and you and Arnold Horshack are having a conversation, right? Benicata, welcome back. Okay, so this is another way to fade our supports. As time goes on, they put in what they know, and they are showing us the work to get to that answer. I already give the answer because I want the work to be shown with reasoning. All right, here's some other ones in here. You might be doing an area model. It's just a distributive property. I know I got a couple minutes left. It's the distributive property. 7 tens, 4 ones times 2 tens, 8 ones. 7 tens times 2 tens. 7 times 2 is 14. 10 times 10 is 100. 4 ones times 2 tens. 4 times 2 is 8. Ones times tens is tens. The answer, 8 tens. Distributive property happens everywhere. 7 tens times 8 ones. 7 times 8 is 56. Don't just put zeros in there. Make them say this. Tens times ones is tens. Because in decimals, it's really going to stand out if they don't know the pattern. 4 ones times 8 ones. 4 times 8 is 32. Ones times ones is ones. 32 ones. Then you get it. Add them up. Add up those products and get that final answer. So this is a partially worked problem example. So guess what? I'm not going to ask all of this at the same time. What if the student hasn't mastered 7 times 8? Can I still teach this problem? Well, yeah. You set up and say, I'm going to teach you and focus on 8 first. I'm not going to make 7 times 8 that clever. I'm going to give them the 7 times 8. That would be one step in this. And then I'm going to make them fill this in. If they're having problems with place value, I'm going to say, this answer will be in hundreds. This answer will be in tens. And again, I am fading that work over time. It will be less and less. I'll have strategically put in blanks, as I call it, so students know what to do, where to do it. And my formative assessment data is going to show me where that error is. That doesn't mean I just give up on a step. That means I give some support directly on that step. Now, so be it if you are into CRA. CRA is great. Concrete, representation, abstract, sequence of instruction. A great approach to show you how to do certain math steps. If you do a good concrete measure that actually addresses real number theory, not all concrete does, you can re-show how computation occurs within more complex math. All right, final one here. My final thing I'll have for you is it's build out that partially worked problem. It's called a helps strategy. We're going to simplify, right, the goal. We're going to help them. We're going to simplify common expressions here. We're going to help them receive intervention, pre-made steps, arrange those steps, and grade. This is an easier way to do it. I didn't even give you the mnemonic because it's just out there. But take a look. This is a complex math problem. If you're not a secondary person, adjust it for you. These are all the, Google, these are all the math computation steps, and I make them put reasoning. Remember I said all of math is a proof. So we want them to put this in order. I want them to show the computation step and why. The computation step and why, computation step and why. The order of ops. Now, if they don't know the order of operations quite well, right? They don't know gems, then we have to work through gems, right? Groups, exponents, multiplication, addition, subtraction. All right. So this is one way to do this. And so they're going to go through and they'll put in steps. Over time, though, let's say that I don't want them just to do this. I have some computational expectations, which means I'm going to put in some blank pieces for my fully worked problem steps. Now they have to put it in order and fill in the blank. As time goes on, more blanks. They have to put together the problem, fill in the blanks until you got it. It is completely independent. That is, again, another fading problem so that I give a lot of support up front and I purposely fade that support as time goes on. If you remember doing this, proofs are not just for geometry. Proof is the purpose of math, logical, stepwise reasoning to make sense of the problem. That is what all this is. And I apologize for the glasses dropping. That's not a looking down thing. That's a old man slippery nose. But these are the steps that go with it. This is a math proof. So I hope that's helpful. Different ways to make math a proof. Get involved into the steps, grade them by steps, make reasoning per steps, and support them through the process. I hope that was helpful. So again, there's another one, right? Where you can see the teacher here, the students, this is the student's hand. They have to move, right? They're on that whiteboard. They have to move the steps into place to put this in order, right? They have the reasons here and the math statements here. And some of these are not statements that will help them solve the problem. They have to put them in order so that it starts to look like this. Again, these students are putting this in order in geometry, and these are students with identified learning disabilities who had difficulty memorizing all the properties and postulates. This comes from a middle school, same thing. They're putting them in order, and she made a puzzle out of it, right? And it's the same thing. She mixed them up and made them reorganize it to it. So in my last minute here, when you're doing this, you're going to choose a multi-step problem, task analyze, practice a fully worked problem, write those steps on cards, put reasoning on another set of cards, and fade those steps and put in blanks in their place until students are completely independent, right? Embedded proficiency is our last one. Teach them to become proficient in computation, support that while we're teaching complex math. So guys, I appreciate I'm at the end of my hour right now. It is 10:45. I am done. So as you conclude, write some friendly thoughts in there. things you can take from today and one question, and then we will simply conclude. Thanks, guys.